Hello, I'm Yoon-seo from Dongguk University DTM Lab. Today, I'll be presenting a paper review on the topic extraction and linking of motivation, specification, and structure of inventions for early design use. First, here is the bibliographic information of the paper. This study was published in 2023 in the Engineering Design Journal. The following are the keywords in this study. Presentation follows the same structure as the paper. Patent research is important for design innovation in companies. Patents can be materials that support idea generation. Also, product development can be supported by patents. In particular, this identification provides insight into what vectors drive design. This can be known from customer needs and reviews. Conceptual design determines solutions to meet product functions. Patents are important, but patent analysis can be a difficult task for designers. Most papers dealing with patents and design focus on developing frameworks that can support design activities. Among design-related papers, there are few papers that deal with data science topics and even fewer papers that deal with the problem definition stage of design. This means that there is a lack of database patent research for early design use in the problem definition stage. Therefore, this study aims to provide designers with insight into existing inventions. For this, the study takes an approach to identify and map design knowledge to need identification, product requirements, and conceptual design. The three types of knowledge are referred to as motivation, specification, and structure. Design methodologies provide insights by converting patents into a form that designers can easily understand. Related studies include research that builds concept graphs from patent claims and research that extracts design information from patents using the function behavior state model. Also, there are studies on knowledge representation between patents and network-based approaches that allow designers to explore technical concepts in patents. Also, studies that drive and expand design ideas based on patents. Related to this, there are studies that support solution generation using the trees database. However, most studies do not sufficiently consider the motivation of inventions. Problem definition and requirement analysis are carried out based on expert-based analysis, and network analysis lacks tracking to individual patents. Therefore, it is necessary to include the motivation of inventions and to have a structured analysis that follows the flow of problem function solution. There are also patent analysis studies based on natural language processing. They extract technical components and relationships or use part of speech tagging and parsing to identify functional requirements and design parameters. There are also patent function modeling studies that identify subject, action, object. In addition, sentiment analysis helps decision making by analyzing reviews, but it has not been applied to patent analysis. In patent descriptions, sentences that contain negative sentiment explain the limitations of prior art. If the limitations of prior art are identified, the motivation of the invention can be understood. Both embedding vectorized text and makes it possible to perform patent classification and build networks. Many related studies have been conducted and several graph examples have been constructed. The study collected data using Google Patents. The title, date, applicant, and link to patents are collected in a spreadsheet. After that, patent contents is collected through web scraping using the links. The motivation is extracted using the full description section of the patent. Sentences that clearly contain motivation are extracted through string matching. After that, sentences with negative sentiment are identified through sentiment analysis. At this time, sentences classified as negative with a score of 0.9 or higher are defined as motivation sentences. Independent claims are used to extract the specification and structure. This is because independent claims define the scope of the invention. Structure refers to technical components and is expressed in the form of compound non-pares. Specification is a function-centered sentence and includes at least one verb. Pre-processing is performed. Sentence tokenization and stubble removal are conducted. The default stubble list may contain meaningful words, so a stubble list defined in the study is used. Part of speech analysis and normalization are performed. A post-tagger was built, and high accuracy was achieved on the test dataset. After that, noun-pares with similar expressions are pre-processed. Limitation is applied only to noun-pares to maintain parsing accuracy afterward. Chunking and structure analysis are performed. The built chunker achieves high accuracy. Using this chunker, MP and BP are identified. At this time, rule-based serial parsing using regular expressions is added to handle complex structures. Figure 2 shows a comparison example between using only the classifier-based chunker and adding the serial parsing step. Now specification and structure are identified. Sentences that include the verb label are selected as specification candidates. Nodes with MP or DP labels are considered as structure. Hierarchical relation sentences are removed from the specification candidate list. The motivation, specification, and structure derived earlier need to be standardized for analysis. Motivation is standardized using trees parameters, specification is standardized using RFB, and structure keeps the patent terms. Linking the motivation, specification, and structure of an invention consists of two steps, conceptualization and mapping. Motivation conceptualization is performed. Embedding is performed using export, and trees parameters are embedded based on their description sentence. The Pierce correlation coefficient between the motivation sentence and the tree's description is calculated, and the tree's parameter with high similarity is selected as the conceptualization result of motivation. Specification conceptualization is performed. Specification sentences are embedded using export, and RPB function and flow embeddings are generated. As in the case of motivation, the function flow pair with the highest value is selected as a conceptualization result. Structure was not performed because the implementation is complex. Therefore, structure is kept as it is in the patent. Motivation and specification mapping is connected based on the Pierce correlation coefficient. This can reflect the semantic relationship within the patent. The connection between specification and structure is performed using chunk tree-based mapping. An SAO structure is formed centered on the verb, and MP or DP on both sides of the verb are connected. As a result, a knowledge network is built by integrating the conceptualization and mapping results. Evaluation is conducted using 15 patents that belong to 5 engineering invention categories. The evaluation is based on expert analysis and zero-shot text clarification. On conceptualization is evaluated and mapping and excluded from the evaluation. As a result of examining the extraction performance, the performance of motivation and specification extraction is good. It showed results similar to expert analysis. However, the performance of structure extraction is relatively low. This is expected to be due to the complex sentence structure of patent claims. The extracted information is conceptualized with motivation using trees and specification using RFB. The purpose method is compared with expert analysis and zero-shot classification research. Performance metrics are defined to quantify the performance of the proposed method. The evaluation is based on agreement rate between the automatic analysis research and the expert analysis research. Also, accuracy is evaluated based on the total generated research. Based on the evaluation using the metrics mentioned earlier, motivation and specification show high performance. However, structure shows relatively low performance. Or research are lower than motivation, so improvement is needed in the process of converting patent knowledge into standardized design terms. It is built in the form of a knowledge network based on 15 example patents. Search and filtering functions are provided based on nodes or relationships. Possible to explore related motivation, specification, and structure through keyword-based queries. Related knowledge elements are visualized in a connected form to provide design insights. When a specific element is selected, related patents can also be checked. In the early design stage, problem exploration is possible from the perspective of motivation, specification, and structure. Functions are provided to explore related knowledge and trace back to individual patents. Through this, idea exploration and decision-making support are possible. Study has the contribution of structuring patent knowledge to match the designer's thinking flow and improving its ability from a design perspective. In particular, it is designed in a structure that allows understanding of design logic. This method is suitable to be used as an exploration tool in the early design stage and as a tool to support idea generation. This study provides information that can be used in the early design stage based on the patent description and independent claims. Finally, a knowledge network is built so that designers can explore ideas. Also, by tracking back to individual patents, designers can perform additional analysis. However, due to the approach based on pre-trained models, there is a decrease in performance in the conceptualization step.